All right, welcome back. Let's take a look at what are the steps to configure storage DRS and a data store cluster for that matter, right? You actually create that cluster and at the same time you enable storage DRS. It's a little bit different than say DRS with a host cluster, right? When you have a host cluster, you actually create the cluster and then you turn on the different services that you want. You want maybe DRS, HA, vSAN. There are three things you can turn on or not turn on in a host cluster. With a data store cluster, it just has storage DRS. That's the one thing it has. So you basically go into your storage screen, right, where all your data stores are, click on the data center, and tell it to create a new data store cluster, right? That's the first step, right? The name and the location, right? So you're specifying the data center and the hosts, basically host cluster. Then your automation, is it manual or is it automatic? Most time, of course, you'd want fully automated, but again, there are cases when you want it to be manual. Usually you're doing that because of some requirement to interoperate with something that may not work so well with automated storage vMotion, such as data stores that have replication and other data stores that don't, right? Or in situations where you have a stretch cluster, which again, you don't really want to do storage DRS with, but if you're going to have it in that type of situation, you definitely don't want to automate the storage vMotion. You'd want to make sure if you've got these stretch cluster, the admins are basically monitoring over where the VMs are running and where their storage are located, because you don't want to have one VM on one site of the stretch cluster and its storage in the other site. But in any case, most of the settings are right here in the storage DRS runtimes settings page. This is where you set all the different key parameters. For instance, that first one, enable iometric monitoring, right? So that's the ability to look for performance considerations when it comes to storage vMotion. If you uncheck that, it will only do capacity monitoring and nothing else. But if you check the box, it will first of all turn on storage IO control on every data store that's in this cluster, and it will then look at the historical latencies across the data stores in that data store cluster, which by default will check the latency every 8 hours for 15 milliseconds of average latency. So it's a long-term historical view, right? We're looking at an 8-hour window every 8 hours, checking to see whether the latency has averaged at 15 milliseconds or more. In fact, to be absolutely certain, if it's going to do a storage vMotion due to performance issues, it waits for 2 intervals before it makes its first storage vMotion move. So 16 hours have to pass before it even gets to, should it start moving a VM because of potential latency issues. Where utilization or capacity management and monitoring, that's done all the time, and that's basically in real time. In fact, you'll see that's the next parameter, utilize space, which is 80% by default. It'll look for data stores that are 80%. We always recommend have a data store with 20% of free space is always a good practice. It gives you the room for growth and snapshots and things like that. And so we definitely want to keep that here. And so you'll set this to 80%. There's another setting a little further down that's not on the screen capture that sets the differentiation, the differentiator between the data store that's 8%. When it tries to find another data store that's less full, it's going to try to find another data store that's more than 5% different. So it would be silly to move a VM from a data store that's 80% full over to another data store that's 79% full. All right, what's the benefit there? It's going to look for data stores that are more than 5% different, but that's another adjustment that you could apply. What's the differentiator you would like to set to? So, but it's 5% by default. Now, if all your different data stores are all different sizes, that 80% rule is a really good rule, and that's why it's the default. However, if you've got data stores that are all exactly the same size in your data store cluster, then maybe it makes sense to you to have the threshold for space utilization based on an actual free space number instead of a percentage. So that's just another option. Again, I like the percentage model myself just because that gives you the flexibility of dealing with different data stores with different sizes. And that we always just make sure there's always 20% free. And that's what storage DRS will ensure no matter what. Then you choose the data stores that are going to be part of this data store cluster. That's the next step in the wizard. Of course, there's also choosing the hosts, right? So you'll choose which hosts and which host clusters are going to be associated with this data store cluster. So again, you saw earlier that you can set a one-to-one mapping, one host cluster with one data store cluster, with one data store cluster, but you can also have one host cluster be associated with 2 data store clusters. And you can have multiple host clusters associated with multiple data store clusters, that's really the next steps in these wizards. You choose the clusters and hosts that are going to be associated with this cluster, and you'll choose the data stores that are going to be members of this data store cluster. But they put all the options right here. It's pretty easy to see, man. There's no real hidden parameters here. And then when it comes time to let storage DRS do what it is designed to do, it's designed to do storage vMotion, right? So when would it do a storage vMotion? Well, it could do it based on utilization, which is what it always does, and it will possibly do it due to IO metric monitoring if you've got that service enabled. And also, don't forget, there's also storage DRS maintenance mode, where if you were to right click on a data store, select enter maintenance mode, that will evacuate all the VMs off of that data store. In fact, it will move all registered VMs, regardless if they're on or off. Because we want to put the data store in maintenance, we don't want to have the maintenance episode of your data store to cause any potential issue with your actual VM data. So you'll get all the VM data, all the registered VM data off of that data store. Now keep in mind what the automated storage maintenance mode does not do is it does not move templates off the data store. It does not move any unregistered VMs, and it won't move any ISO files. So it's basically looking at registered VMs as the primary target to evacuate off of the data store. And if you happen to have a data store cluster in manual mode, well, then what you'll find is there's a recommendations page, just like there is with DRS, that you can verify whether there are any data stores that need to be migrated based on its calculation. So we can see here it's wanting to migrate several virtual machines, and what's not shown in the capture. In the bottom right hand corner, there is the migrate now option, right? Just apply everything that's got checks in it. It will apply all the recommendations. Over on the bottom left, there's an option to basically override the recommendations, where you can then choose which of those checkboxes to leave a check mark in and which ones to leave blank, because maybe you don't want to move all the different things that storage DRS wants to move. If you were to select the override, you can then uncheck the data stores you don't want to have, the files that do not need to be migrated, and then you apply only the boxes that are checked. This is just like DRS. There's even a run storage DRS button that will do the scan of the cluster outside of its scheduled interval, right? So it does it every 8 hours for the IO matron, all the historical IO latency monitoring, and it will always check in real time for utilization on capacity usage. Now, another interesting thing, when storage DRS does its calculations and it decides to move VMs, when would it do this? It will by default do this as soon as you enable the automated part of storage DRS. It will consider moving the VMs at any time. What if you have a backup window in the evenings where now you're causing your VMs to be backed up at in a shorter time period? That in itself, right, all the backing up of the VMs probably generates a fair amount of disk I/O. So would that cause storage DRS to think there's potential latency issues? Should storage DRS be moving VM files when we're in the middle of our backup window? Probably not. So what's neat with storage DRS scheduling is that it can actually be enabled and disabled on a schedule. So you can put it in manual mode maybe during your backup window and put it back in automated mode when it's outside of the backup window. So these are things you can set up in your storage DRS under the scheduling options. Set it to only do manual settings in a short period of time and fully automated outside of the backup window. So, to kind of wrap up, we have an activity just to kind of refresh everything we were talking about. With a data store cluster, what we have as an example here, we have two VMs. Noticing we have a primary DNS and we have a secondary DNS. If these two VMs are on the same data store, right, how would we really properly configure two VMs that might actually be replicating their configuration, right? What would we do here? Should we keep the two different VMs on the same data store? Is that any concern, right? Well, if you have VMs that are essentially replicas to each other, it's a better practice to have the VMs not just on different hosts, but also on different data stores. So you'd basically create an anti-affinity rule for this solution here to make sure that the VMs, while they can both be in the same data store cluster, they just never should be on the same data store. So the anti-affinity rule would let us configure for that. So that was a look at our storage DRS data store cluster lesson. We showed how to create a data store cluster, how to configure storage DRS, and explain how storage IO control and storage DRS complement each other, right? That's just a reminder that storage IO control deals in the real time, whereas storage DRS is actually looking at avoiding the bottleneck, right? Historical lookups is what storage DRS performs, whereas storage IO control is in the real time. So to kind of put it simply, storage DRS is avoiding the bottleneck, storage IO control is dealing with the unavoidable bottleneck. So key points for the entire module, right? We've now gone through the storage scalability module. Remember, we talked about VMFS version 6. The host will automatically send the unmapped key or the unmapped commands to your storage array for the ability to have automatic reclamation. Storage API for storage awareness. VASA will use storage vendors can advertise their storage capabilities to advertise their capabilities to this from the storage arrays to your vCenter server. The storage APIs for IO filtering, and that's VMware and third-party vendors can create data services such as caching and replication. Don't forget, there's also built-in encryption and storage IO control. Storage policy-based management abstracts the storage and data services delivered by vSAN, virtual volumes, and IO filters in traditional storage. Right? We talked all about storage policies, right? For traditional storage policies to vSAN storage policies to virtual volume storage policies. Storage IO control is a way to create cluster-wide storage IO prioritization. And Datastore cluster was allowing us to have storage DRS as a collection of data stores working together to balance storage capacity and IO latency. Yeah, that was a pretty extensive module, so we made it through. Very good. Go take a break, and we'll come back for the next module. We'll see you in the next one.